We'll proceed in partial Jacobian in calculus. If cross Jacobian is used for the surface calculation, full Jacobian used for volume calculation, then what is partial Jacobian? We have talked about partial Jacobian. Partial Jacobian means if I have two dimensions dx dy. What is Jacobian? So many times we are talking about Jacobian. So Jacobian is Jacobian is primarily Jacobian is primarily used when we cannot do the integration. Integration is the solution of my problem. I know. Integration is solution to my problem. I know. But I am not able to calculate the integration. Somehow it is so complex. There is a sharp differentiation between integration and differentiation. Differentiation, especially the chain rule, break the differentiation into part, and as we go along, it becomes smaller. What is differentiation of square root of x square plus y square by dx? What is differentiation of a square root of x square plus y square by dx? Differentiate with x square plus y square, it becomes 1 by 2 x square plus y square to the power minus 1 by 2. Now 2x. Integrate a square root of x square plus y square by the same chain rule. Okay, product rule. I mean integration by part, not parts. Okay, it is too difficult. So scenario is that integration and differentiation, though they are part of calculus, like multiplication and division are part of mathematics, numerical mathematics. So integration and differentiation, something like it is part of algebraic mathematics, then they are different. Calculating integration is very difficult. So at that time, we need some kind of help. We need some kind of, it is also called delegation. So if we are doing integration into x, y, z as difference, there are three parts in integration if you see carefully. One is called limit. One is called limit. If limit is single dimensional means it is interval. If I am doing integration along x-axis, then it is single dimension. Then one point to other point in x-axis. This is also called integration. So integration limit one point to another point, it is also called interval. It is called interval. Now, if this is xy plane, the integration is along xy plane, then rather than 2 point on x-axis, now it is a region on xy plane. So, if I want to do integration of this circle along x-axis, then I can do integration from a particular point on x-axis to a particular point on x-axis. Now, integration calculate the area. So, okay, I can do like this. It is centered at the origin, and if I do the integration, then from one point to other point, this area it will calculate. Now, integration of any surface along xy plane. If this is a surface, then integration of the surface, we are calculating volume. The volume underneath the surface that is hitting the xy plane. Now, wherever I am seeing my fingers, this region is called the intersection region of this sphere, of this surface, or particularly I want integration of this surface, means calculation of this surface on xy plane, where the region on xy plane is confined by a rectangle. The region on xy plane is confined by a rectangle. So If I am integrating along x-axis, then there is an interval. If I am integrating along xy plane, then there is a region. On this region top, if there is a surface, this is a surface on top of xy plane, and there is a defined region, it is a rectangle or it is a circle, whatever it is, that region would go up and it will make an area on the surface. That area, if it comes down, then it will hit the rectangular region. That volume we are calculating. So the limit, if we see integration, the first section is limit. If integration in 2D, the limit is a region. If integration is 1D, the limit is an interval. If integration is 3D, dx, dy, dz, the limit is cubical, 3D. After that, it comes an integrand, fxy, fx, fxy, fxyz, function over xyz. It is also called density function, fxy, 3D function. A z over x and y, fxy, 2D, y over x. And now dx or dx dy or dx dy dz. Okay. So first is limit, second is called integrand, and third part is called differential. So for single dimension, single limit, it is dx, double limit, it is dx dy, triple limit, it is dx dy dz. And then we have integrand as function over x, xy or xyz. So now if we are in a mood to calculate some integration, and then when we write this integration, at that moment we feel that we cannot do it. It is very difficult. In that way, now we start thinking about some kind of substitution. So method of substitution in integration, it leads to complexity. So if we try method of substitution, then we have to change our x, the limit region. We have to change as per the substitution, because if it is x, y, z, then x equal to what we have thought, y equal to what we have thought, z equal to what we have thought. Accordingly, integrand should be modified. Accordingly, differential part should be modified. And accordingly, the limit should be modified. The modification of the differential part, here the fundamental of Jacobian comes into the picture. So, like if I have fxy, dx, dy and integration over a region on xy plane, there is a two-dimensional region. Then fxy, if x equal to guv, now xy I delegated to another substitution called u and v. X is now a function over u and v. Y is a now function over u and v. X equal to guv, y equal to huv, or I can say x comma y equal to capital T in braces u comma v. This is called transformation. So now if that is the scenario, then we can change the integrand accordingly. Whatever we have thought, x equal to a function over uv, y equal to a function over uv, accordingly I can change the integrand. Similarly, dx dy is nothing but differential over xy plane. So dx dy I cannot change directly to du dv, because there is a function, right? X equal to some function, then uv, y equal to some function over uv. So dx dy, if it is dx dy dxy plane, I can write as dxy by duv into duv. So duv becomes du into dv. This dxy by duv, this factor becomes Jacobian. Means this one someone needs to place there to convert dx dy into du dv. Now the integrand, that is fxy, can directly be changed into fu, a function over u and v. Changing x to uv, f guv, any function guv, and changing y as huv. The integrand would change. What about the limit? So we are done everything little bit. Limit we have started, and limit we cannot underestimate. People generally they focus toward Jacobian. People they focus toward integrand. No one focus about the limit, and limit becomes a Waterloo. Directly, indirectly, it becomes a Waterloo. So we will see the concept of limit and then partial differentiation again. Do we need full dx dy to convert into another coordinate system u or v? Is it really required? That is the concept. Or can we go for partial Jacobian? Partial Jacobian means dx dy, one of them only I'll change, making it to single dimension Jacobian. Partial Jacobian means single dimension Jacobian. That is easy. So dx dy, can I think it as dx and then for dy I say dy dy as dy by d theta into d theta. Dy by d theta is Jacobian. It is far easy because if you go for dx dy and then u and v, you have to come to a matrix because two dimensional. Single dimensional matrix means directly someone can do. So partial Jacobian, this is our research. Partial Jacobian probably it will not be available in any of the book. So partial Jacobian, can we proceed as per the promise that we have made that through partial Jacobian we will calculate the surface area of a cone. What is surface area of a cone? That is always under question. Okay, so I have a right angle cone. I have a right angle cone. Right angle cone is a cone. Actually, this much time goes I could not arrange a cone. Okay, now I have a right angle cone. Right angle cone means that this cone would completely sit on top of xy plane on a flat surface. Right angle cone. Okay, this surface should be completely flat. So right angle cone, this part is a circle. Now when it falls on xy plane, this part is a circle and this circle is of radius a. This is blue color is the center. So this cone sits on top of the center, radius a. If that is the case, then it has base as a circle which has radius a and height is h. So this is the base of the cone, and consider this is the height of the cone. If this if this is the height of the cone, then okay, if this is the height of the cone, then this is the slant. This is the cone, or I can just hide this. This is the cone. Where this is the height of the cone. This is the radius of the cone. It is like this. This is the cone. Okay, this is the cone. Now this radius is a and height is h. Now if this is the cone, if this is the cone where base radius is a, if I cut if this height is h, if I take any height z and I cut it, it becomes a circle again of radius r. Consider a small r. Then small r is a small circle and a is a big circle at the base. And this is z, this is any height z at which r is there. This height is h minus z. Full height is h. h z h minus z, radius r, radius a by h equal to r by h minus z. So this is the equation we saw. A by h equal to r by h minus z. H minus z equal to r into h by a. H minus z equal to r into h by a. Z equal to h minus h by a r. Z equal to h minus h by a r. Radius r is nothing but x square plus y square square root. Okay, now what is the surface, how we calculate the surface. So if we see the Cartesian coordinate system, if you remember very well, then calculating the surface is nothing but I take any point P here, that is the position vector. If this is the position vector, then dp by dx cross dp by dy, okay, whatever the magnitude is there, multiplied by dx dy, or dp by dx cross dp by dy is nothing but d surface area, d surface area by dxy, d surface area by dxy, that is the change in the surface area when there is a unit change of the area on the xy plane. D surface area by dxy plane. Now, this is surface area but divided by xy plane. If I multiply it with the xy plane, I get the surface area. This is the aim is, not this surface area, only the slant surface area. So, d surface area by dxy plane into dxy plane. D surface area by dxy is the Jacobian, whatever you consider, into dxy plane, that is dx dy, integration with dx dy. Now d surface area by dxy is nothing but dp by dx cross dp by dy. What is, little bit I'll tell you again, I believe I have repeated so many times. So if it is xy plane and there is a surface area on top of it, the surface area is fxy or z. This is xy plane. If I draw a rectangle on the xy plane, this rectangle will go and it would map to some region on the surface area. If there is a unit change in this rectangle, meter square, millimeter square, whatever the unit is, if there is a unit change in the rectangle, rectangle is either growing or it is shrinking. If there is a unit change in the rectangular area, it is the mapped region here on the surface. How many of unit change we see here? One unit change here brings how many unit change here? That is the surface area by dxy plane. So that is the case now. So what is the surface d, that is dp by dx cross dp by dy, because any moment surface area, if I take position vector, dp by dx is p position vector is xi plus yj plus zk. P point, any p point on the surface is x comma y comma z. So position vector is xi plus yj plus zk. dp by dx is I plus dz by dxk. dp by dy is j plus dz by dy k. So dp by dx, I plus dz by dxk, there is I and k. So in xz plane, if this is x-axis, y-axis, z-axis, in xz plane, dp by dx moves. dp by dy moves in yz plane. Okay, if that is the scenario, then at any moment on the surface, if this is the moment of surface, if this is dp by dx and this is dp by dy in xy plane, it looks like a parallelogram. Parallelogram. Cross product of dp by dx and dp by dy would give the area. That's why it is dp by dx vector, whatever the, consider this is vector A and dp by dy is vector B. A cross B is nothing but the area between A and B, but A is velocity vector, dp by dx, not P. And B is velocity vector, dp by dy. If that is the case, then it is giving dp by dx and dp by dy is dp by dx and dp by dy, dp by dx cross dp by dy is giving actually the d surface area by dxy plane. If it was a p vector, then it would have given surface area. So d surface area by dxy plane. If that is the case, then now how we can proceed on it? So calculating the surface area of the cone. What is P? Xi plus yj plus zk. So dp by dx is I plus dz by dxk. dp by dy is j plus dz by dyk. If I do cross product, then it becomes minus dz by dxi minus dz by dyj plus k. If I calculate the magnitude, it is dz by dx whole square plus dz by dy whole square plus 1 square root. and then integration over dx dy. Means d surface dp by dx cross dp by dy is d surface area by dxy. Now I have to get the surface area, I have to multiply with the dxy. So, so then now this calculate this magnitude or integrate with the dxy, dx dy. Now this d surface area by dxy is dz by dx whole square plus dz by dy whole square plus 1 square root. Now what is z? We saw that r by h minus z equal to a by h as per the cone. If this is a, this is height h. At any height z, this cross section radius is r. So z equal to h minus h by a into r. R equal to square root of x square plus y square. At any moment, what is the r? R in that, if I take that cross section area, r rotates 2 pi degree. R rotates 2 pi degree. Any moment r is at angle theta from the x-axis. So x is r cos theta and y is r sin theta. This is hypotenuse. That case x square plus y square equal to r square. Now what is dz by dx? Dz, if z equal to h minus h by a square root of x square plus y square, what is dz by dx? If that is the case, then dz by dx is minus h by a minus h is gone minus h by a and then 2x by square root of x square plus y square. Dz by dy is minus h by a minus that is x. So dz by dx is minus h by a into x by square root of x square plus y square. Dz by dy is minus h by a y by square root of x square plus y square. Dz by dx whole square plus dz by dy whole square plus 1 square root. That would come at h square by a square into x square by x square plus y square plus h square by a square y square by x square plus y square plus 1. Now first two term I can take out h square by a square, then it becomes x square plus y square by x square plus y square. This proof is not available anywhere else. This is completely our proof. Go and check calculating the surface area of a cone. Now then it becomes 1 x square plus y square by x square plus y square. Then it becomes h square by a square plus 1. Now it becomes a square root of h square plus a square by a. Okay. Now integration of this with dx and dy. Someone would jump now because there is nothing x and y here. A square root of h square plus a square by a dx dy cakewalk and x. Now this cone is now the cone what we have. Now cone is based the circle of the cone, the base circle of the cone falls on the xy plane. So that is a circle. Now in the circle, this is the circle where x is minus a to a and y is minus a to a. Can I take like this? We were taking like this. X limit is minus a to a and y limit is minus a to a. X limit is minus a to a and y limit is minus a to a. Now we'll proceed on this. We can go step by step. So now we will proceed. This is called region on the xy plane or integration over a circular region. If we are talking about integration over circular region, now we are entering into again a different world. Now we say conversion of dx dy in past videos through Jacobian, the different coordinate system. Similarly, integrand is also modified into different coordinate system. What about the region? How we modified the region? Now the region, if I take x is minus a to a and y is minus a to a, this proves that the rectangular region is rectangular. The region on the xy plane, the limit is a region. If limit is a region, the region must be rectangular to have x and y independent of each other. But it is not rectangular, it is a circular. If it is a circular, then if I take x as minus a to a, then y is square root of a square minus x square minus square root of a square minus x square to square root of a square minus x square, because it is not a rectangle. What do you mean it is not a rectangle? If it is a parallelogram, then again it will be dependent on each other. One will be dependent on other. If it is rectangular, then only we can take the numerical limit, because if x is minus a to a, y is not dependent upon a because it is a flat line. If it is a flat line, I cannot say y equal to some x. Straightforward, I can say y is here lower limit to higher limit, x is lower limit to, because if it is rectangular, x and y, they are perpendicular to each other. If they are perpendicular to each other, they are orthogonal. And orthogonal components are considered as independent, typically. But here, the base of the cone is circular. If base of the cone is circular, we cannot take the limit x is minus a to a and y is minus a to a. Y is dependent upon x because it is not a rectangular. What is the solution? Solution is go for another coordinate system like polar coordinate system. The polar, if there is a circle in xy coordinate system, the equivalent of polar coordinate system in the polar coordinate theta, it will be a rectangular. Is it the aim of a integration is to change it to rectangle? Yes. This is called parameterization. What is the aim of the parameterization? This is the $1 billion answer I am giving. What is the aim of parameterization in method of substitution in integral calculus? The aim of the parameterization using different calculations, the different coordinate system, is to change the limit region from non-rectangular to rectangular. That is the main concept. If there is a circle in xy plane, the circle can become rectangle only when someone uses polar coordinate system. But here we are talking about partial coordinate system where we are not taking both dimension as changing the x and y both. Only one I want to change. Partial Jacobian. In that way, if there is a circle that is a base of, there is a, now the cone, earlier the limit was in xy plane, it will be in xy plane, but x is minus a to a, or reverse fashion I can say x is from minus square root of a square minus y square to a square root of a square minus y square, and y is minus a to a, or x is minus a to a minus a to plus a, and y is minus a square root of a square minus x square to plus square root of a square minus x square. Let's take other way. X is minus a square root of a square minus y square to plus a square root of a square minus y square, and y is minus a to plus a. This is the circular region because it is not rectangular. So now our integrand is square root of a square plus h square by a dx dy. The integration limit is from minus x is minus a square root of a square minus y square to a square root of a square minus y square, and y is minus a to plus a. Boss, it looks very difficult. Then go to polar coordinate system. No one has stopped you. But we are committed to use only one Jacobian, not two. So let integrate with the dx. So integration of dx is x. X is minus a square root of a square minus y square to plus a square root of a square minus y square. That will come as 2 into a square root of a square minus y square. Okay. Now 2 I can keep outside, and square root of a square plus h square by a I can keep outside. Now I have 2 by a into a square root of a square plus h square. Now, okay, and now the integrand is square root of a square minus y square. So a square root of a square plus h square by a into 2, and then now integration of y from minus a to a, integrand is square root of a square minus y square dy. Now doing this integration, now here I will use Jacobian. Now consider y equal to a cos theta. Y equal to a cos theta. This is not polar, something else. Y equal to a cos theta. Then a square root of a square minus y square becomes a square root of 1 minus cos square theta. A sin theta. A sin theta. And here, now dy I can write as dy by d theta into d theta. So dy by d theta, if y equal to a cos theta, then dy by d theta equal to minus a sin theta. Now I'll replace here. Dy by d theta is minus a sin theta. Now I have a sin theta minus a sin theta, a square sin theta minus. So now minus a square I'll keep outside. Outside already I have 2 square root of a square plus h square by a. Now minus a square is going there. A cut down, only a will remain there. So minus 2a square root of a square plus h square. And here integration is sine square theta d theta. Integration of sine square theta d theta is theta by 2 minus sine square 2 theta by 4. Now limit is minus a to a. Minus a to a is in y, not in theta. Now move ahead. Now y equal to a cos theta. If a is minus a, then theta is pi minus 1. When y is a equal to a cos theta, then theta is 0. So pi to 0. Theta by 2 minus sine square 2 theta, sine 2 theta, theta by 2. Sine square theta integration is theta by 2 minus sine 2 theta by 4. Pi to 0, 0 gone. Pi sine gone, only pi by 2, minus pi by 2. So minus was outside, minus plus. Pi by 2, 2 cut down. Only pi a remained there. Pi a square root of a square plus h square is the surface area of a cone. This is partial Jacobian. Only one dimensional I use as Jacobian, not the full x and y. I converted into theta and r. We have done full Jacobian also while calculating the surface area. Please watch that video. Where full Jacobian, I believe two video back. Full Jacobian we have used to calculate the surface area of a cone. One Jacobian we use to calculate the surface area of a cone. We will proceed in partial Jacobian. It is very useful. Means no need to go for cross product of a matrix and imagining this and that. Not required at all. Partial Jacobian. Our Jacobian. Partial Jacobian is not mentioned anywhere else. This is our research. Partial Jacobian. Please support us. +91 is India country code 94831 60610. 94831 60610. This is the telephone number, and +91 is the India country code. So please support us.